Hello! Today we're going to talk about 4.1 quadratic functions and transformations. So hopefully you remember all of this literally in the last section. Okay, so now we're going to be more specific and focus on quadratics. Okay, so we're going to focus on graphing quadratics. Now notice I didn't put the b in there mainly because if you think about it, a b movement is very similar to an A transformation. Okay, it's just kind of like in a different location. So when we do a reflection across the y-axis, well, if this is our parabola, the reflection is the same thing. Okay, because we're flipping it across this axis. Okay, so the B just, I don't know, isn't as useful, right? And plus we can take shortcuts with the other stuff. So I'm going to show you how to graph quadratic equations and hopefully with some shortcuts, but B is kind of a weird thing. Okay, just keep that in mind. So let's do this one. So this is the parent function. So let's say I have no idea what I'm doing, no idea what the equation is going to look like. So I write it out and I'm just going to pick numbers. Now I provided the graph for you, so you know that all my x values go from either -5 to 5. So just start plugging stuff in, right? I can go all the way down from, let's see, from -5 to 5. Now I skipped a few, okay? It doesn't matter. You could have done the evens and skipped the odds. I don't care. But if you have no idea, start plugging in these x values, okay? Because on the graph they provide you, it's got to be in there somewhere. So we take these x values and we plug them in here. So if we plug -5 in, well, -5 squared is 25. If I plug in -3 squared, that's 9. Plug in -1, plug in 0, plug in 1, plug in 3, plug in 5. Okay, so -5, 25, that's way off my graph. I'm not going to graph it. And same with the -3, but -1, 1, and 0, 0, 1, 1. Those were all on my graph, but I don't have anything else because the next thing was way up here. So maybe I should plot -2 and 2. So if I plug in -2, I get 4, and if I plug in +2, I also get 4. So now I can see all my points, and now I can graph it. Now this is very similar to a absolute value, except the slope doesn't stay consistent, right? This is a slope of 1, this is a slope of 3. So what that means is that this is more of a U shape. So it's not a V shape, it's a U. So you want to make sure it's rounded. Make sure this is not a point. If you make this look like a vertex, or like it was an absolute value, a sharp corner, I'm going to take points off. Okay, don't do that, it's rounded. Okay, so this is my parent function, aka the OG. All right, now here we can graph 2 more. So again, you want to just plug in your points, and you can literally plug in all the values from -5 and see what you get. Now, I can tell you right now, people mess plugging this up all the time. Think of there's parentheses around that x. Now, what do you do first? Do you do the negative or the squared? You know this, you do the squared first. So when you do this, you want to square your x and then take the negative of it. Okay, so we square the x, we get 25, then take the negative. Square it, then take the negative. All right, so hopefully when you're plugging these in, you're getting this. Again, you can pause the video and then check. So this is if I have no idea what I'm doing. I'm plugging in everything, and then I'm just putting points on the graph that fit. Okay? So we have -2, 4, -1, 1. There we go. So now you're getting this. Well, if we had thought about our transformations, a negative is a reflection across the x-axis. And isn't that what I just did? I flipped from here, and then I went down, had the same exact slopes. Okay? So if you know your transformations, you can do things like that. Okay? Well, then what's going to happen when we change our a value? Okay? Because for absolute value, it was really nice and simple because it was just the slope of a line. This is not a line. Our slopes are doing weird stuff here. So let's graph it and see what happens. So we're going to plug in all of our values. And I will show you a shortcut. But we got to investigate first. So we plug this in. We do x squared first. So square your x and then multiply by 2, because that 2 is not part of being squared. So we should get, what is that, 50? Okay, so we plug all those values in and we get this. So then when we graph them, all right, well now I start to have stuff going off my graph. So yeah, I probably should have given you a better one here, but here, if we go ahead and plug in 2 and 2,8 and -2, 8, it's only a little bit off my graph. So it's just right up here, right up here. So we're still going to round it out the best we can. Okay, so yeah, it's going through my equation, whatever. So now, let's analyze our slopes, right? Let's do this shortcut. So if we look at our parent function, we went up 1, right 1. Then we went up 3, right 1. Then the next one at 3, 9, that would have been up 5. Ooh, if I can write, that might help. So we went up 5. So we went up 1, up 3, up 5. And the next one after that would have been 7 and then 9. Okay? So your slope, if you want to think about it like this, goes in odd numbers. So if we go from the vertex point to the next point, it's 1. The one after that, it's 3, then a slope of 5, then 7, and we keep going on forever. So, what's the shortcut here? Well, if we look at the slope here, we go up 2 over 1. So the slopes here was 2, and then we count this, and then it's 6. So the difference here was 2, then it was 6, then it was 10, then it was 14. All right, well notice what the difference is. That's 2 times 1, 3 times 2 times 3. Might help if I write it in the same format. And this was 2 times 5, and this is 2 times 7, and I can guarantee it, the next one is going to be 2 times 9, because we're doing 2 times our slopes. Remember, slope was 1, 3, 5, 7, 9, and so on. Well, notice what we multiplied by. The slope was 2. Ooh, did not meant to use my pen there. All right, so the slope was 2. I'm sorry, A was 2. So now our slopes, our odds, get multiplied by that A value, and then it's easy to graph. Now, this works out really nice if A is a nice whole number. If A is a decimal, or you have B, you know, a B value somewhere in your graph, then don't do it. Don't do this shortcut with the slopes, okay? But well, here, let me show you. Well, it's better with examples. So like for number 4, if you're unsure, well, I don't want to sit here and keep graphing out a million things, right? But it follows your transformations. So if we're going -1, -4, that means we're going right 1 and down 4. So I know my vertex is there. So if I want to graph this and I don't want to use my slope trick, I plug in 1, -4, and I pick my values around your vertex. So pick numbers above it, so 2 and 3, and pick numbers below it, 0 and 1. Then we plug those into our equation. So 3 minus 1 is 2, 2 squared is 4, 4 minus 4 is 0. Plug in 2. 2 minus 1 is 1, 1 squared is 1, 1 minus 4 is -3. Plug in 0. Plug in 1. Did I? Oh, I did this one wrong. Silly me, I hope you caught it. Okay. When you plug in 3, 3 minus 1 is 2, 2 squared is 4, 4 minus 4 is 0. Wait, what? I'm being a goofball. Oh. I'm not supposed to plug, I'm plugging in -1 down here. I'm being silly. So there we go. The reason I was freaking out thinking I had the wrong answer is because if you hadn't noticed yet, once you find your vertex, the y values around it should match. So if I went up 1, down 1, down 1, these values should repeat themselves. Okay? That's why I knew I was doing something wrong. I couldn't figure out what at first. So let's see. We have 0, -3, -1, 0, 3, 0. And notice, because these are supposed to be symmetrical. So we round it out, and we keep it going to the edge of the graph with arrows, because this goes on forever. Okay? Again, shortcut was, I just plot my point, 1, 4, up 1 over 1, up 3 over 1. Next one would have been up 5 over 1, and I could have matched it over here. Okay, so let's see. Let me show you in this next one. So for here, we could think of this as -x plus 0 squared plus 2. So our vertex is going to be at 0, 2. I don't know why I decided to make it a negative. Okay, so we have 0, 2, and our m is a -1, or I'm sorry, our a, I guess I should say. Our a is -1, so our slopes were 1, 3, 5, 7, but now they're going to be -1, -3, -5, -7. We're multiplying them all by a. So a slope of -1, down 1 over 1, down 3 over 1, down 5, so like over 1. Do the same thing, down 1, we're just mirroring it. So again, this was the shortcut. Ooh, didn't quite match, but that's what I get for not having a large enough graph. You get the idea. And again, if we didn't want to do it that way, we could have just plugged in our points and gotten this as our t-chart. Let me write it down. Okay, so that would have been your table if you didn't want to do the rapid graphing. All right, let's keep it going. So let's see, I prefer the rapid graphing, so I'm going to show you that again. So here we're going to have plus 0. So our vertex is going to be at -3, 0. Our a value is 2. Our slopes were the odd numbers. So now our new ones is going to be all those times 2. So 2, 6, 10. So we plot the vertex, so -3, 0. And we just do these slopes. Slope of 2, up 2 over 1. Then of 6, up 6 over 1. Now I don't have enough room for that 10, so I'll leave it there. Up 2, left 1. Up 6, left 1. So I make it symmetrical. So here we have our parabola. Okay, so that's all you need to do, and see how I can show my work. If you don't like that, then you go ahead and make your table. I would make your t-chart around your vertex, so -3, 0. Pick numbers above that and below it, and you're going to want to plug them in. So these should be 2 and then 8. Okay. So number 7. Okay. If we want to do, now again, I'm telling you this is tricky, but I'll show you how to do it with decimal form, but it's not going to give you nice ones. But if you're trying to estimate or do a quick sketch of your graph or do like a quick comparison, this, I'll show it to you. Okay. So here our vertex would be 0, -3. So here we've got our point. Our A value is 0.5, so now our new slopes are 0.5. 3 divided by 2, so, or 3 times 0.5, so 1.5. 5 is 2.5, 7 is 3.5, and so on. Now, when we graph these, we always graph this version. You cannot graph it otherwise. The rise over run is always over 1. So when we graph this, we have to rise halfway and run 1. Rise 1.5 and run 1. Rise 2.5, run 1. So see how this can get real nasty real fast with decimals? Where it's pretty easy to count halfway, but what if this was go 0.34? 0.34, and then you're moving things crazy decimal amounts, right? Very, very gross. But 0.5, I can count by those. Then let's see, what's the next one? 3.5. So then over here I do the same thing, but I go left instead of right. And it's not too bad again with a 0.5, but that's tricky because you don't know if you're going to get other ones like that. Okay. So if you were to do this with a table, which would I recommend whenever A is a decimal or you have a B value, all right, I would graph the vertex, pick numbers above and below. And then these, I believe, don't come out so nice, but that's okay because I want them to become, I can leave them as decimals because it's easier to plot a Y value as a decimal. And then if we plugged in 2, we would have gotten -1. Okay. So let's keep going. Okay, I'm going to do one more with you. So here we can do rapid graphing. So our vertex is at -2, +3. So our A value is -1, so our new slopes will be -1, -3, -5, -7. So that means everything is over 1, rise over run. So down 1, right 1, down 3, right 1, down 5, right 1, down 7, 1, right? We can keep going on for forever with this rapid graphing. And then we just mirror it. So what am I doing? 5. Oh, I didn't count my 7 right. So let's see. I just went off a little off my graph just because I like to make it more exact. But you could have stopped here and actually gone through that point and then stopped your line there. That's fine. Okay, so if we wanted the t-chart, I would plug in your vertex numbers above, so negative 1, 0, and numbers below, right? Kind of like a number line. So when you plug these into your equation, you should have gotten negative 1 here, 2, 2, negative 1. All right, so that's how you do rapid graphing, or how you graph in vertex form. If you have any questions, come see me.